Good morning, everyone, and thank you all for standing by. And welcome to today's webinar, Enabling Enterprise Security in the Cloud with AWS and HashiCorp Vault. Our speakers today are going to be Scott Ward, Principal Solutions Architect for AWS Security Partners, and Kevin Cochran, Senior Solutions Engineer at HashiCorp. Throughout the webinar, feel free to enter your questions into the chat box, and we'll be answering them towards the end of the webinar. This webinar is being recorded, and it will be made available after post-processing, usually within 1 to 2 days. And with that, I'm going to hand it over to Scott from AWS to get us started.
Awesome. Thank you. Thank you very much, Peter. And good morning, everybody, and thank you for taking the time to meet with us today. How's that look, Kevin?
You're good.
Perfect. Looks good.
Okay, good. So awesome. So there's a couple of things I'm going to touch base on here today that are going to talk about kind of why are customers ultimately choosing AWS when it comes to security, and kind of help to set the stage of why you would use AWS to run workloads and even additional security products as part of the overall platform. And so to start off with, there are some reasons why our customers have traditionally found security to be so hard when it comes to running in their on-premise environments. One of those has really been lack of visibility, that being able to actually have an accurate inventory of your infrastructure and the data and where the data is stored is incredibly difficult. And even if you're able to actually go and get that inventory, being able to keep it up to date, people to know when things change, be able to know when new stuff comes into your overall data center, or when something becomes unhealthy, is very difficult. And then for the security tools that customers have been running, they've often had not been very conducive to being able to allow a lot of automation. They've been kind of really requiring you to kind of operate more at a human scale, a lot of ticketing, a lot of emails, a lot of manual work to go in and configure and make things work with what you're running in your workloads and your applications. And so these two things combined have really kind of limited customers and what they can really do when it comes to kind of innovating and continuing to grow. And so they've often had to make a decision, a very binary decision. Do they move fast, or do they stay secure? Because of that human scale speed that the security tools need to operate at, that there was a limited ability to kind of be able to innovate and be able to move quickly and be able to have your security tools and your security teams actually be able to keep up with what you're trying to do. So it often kind of limited innovation, and things ultimately moved at a much slower pace. And so with the cloud and with AWS specifically, the ability to have the visibility at all times of what you're running from an infrastructure and from a data storage perspective, and being able to automate your security processes and the steps to configure and secure your infrastructure has really allowed customers to actually be able to now say that they can actually move fast and that they can stay secure. They can start taking advantage of some of the unique value props of the cloud around self-service, around global infrastructure, around elasticity, and still ensure that their security tools and their processes can actually keep up with what they're doing and allow them to really focus on the things that are differentiating them as a business. So AWS works with lots of different customers. We have over 1 million customers operating around the world, and these customers take security very seriously. And so we listen to them and we make sure that we understand what our customers are looking for and what their requirements are when it comes to security. Now, these millions of customers are in the startup space, they are in the enterprise space, they're in the public sector space, and they operate in lots of different industries with lots of different requirements. And so we take that feedback and we use it to help prioritize things that we are building and doing for our customers when it comes to how they're using the AWS platform. And so we have a purpose-built infrastructure that is focused on implementing the appropriate security controls. It's operated and monitored by professional security staff 24/7. We take those things that we are learning and doing and the approaches we have around building that secure infrastructure for our customers, and we apply that to the services that we build as well, whether they be a security specific service or just a service in general, and making sure that the security aspects are baked into that. And so it allows our customers to be able to inherit the security controls that maybe would only exist from some of the most security stringent companies in the world. And what it means is that regardless of the shape and size of customer that you are, you're able to take on and use these security features and functions that we make available for even the biggest customer or the smallest customer. Everybody gets the benefit from these security features that we make available. And so you're able to have or grow your standards as far as privacy and security. You're able to automate with a higher degree of precision and be able to keep up with your business. And most importantly, you're able to leverage the network of global security partners that we are working with that are working to build and enhance it and offer customers the ability to ultimately meet their security goals while they're running on top of the AWS platform. And HashiCorp's a great example of that, where they are offering features above and beyond what AWS has, so that customers can use those to meet their needs and be able to fit those into their business processes and how they deploy their workloads. So when it comes to security, one of the things that our customers are often concerned about is making sure that they can actually maintain compliance. That's often part of our security discussions. And so what we've done is that we have gone out and we work with these global compliance bodies to understand what their requirements are and how those need to be met. And then we work to actually build and operate those controls for the AWS infrastructure and services. And then we work with third-party auditors to actually go through and verify how we're operating these controls. And then they issue those third-party attestations saying that the AWS portion of the overall AWS, the AWS portion of the overall AWS platform, which we'll talk about in a minute, meets these compliance requirements. And we make those third-party attestations available to our customers. And what it means is that our customers can actually build and operate compliant workloads on the AWS platform, because they're able to inherit the security controls that exist for the AWS infrastructure, and then they just get to take their security professionals and focus them on the workloads and the applications that they're actually deploying and running on top of AWS. They still need to make sure that they're meeting the compliance requirements for that portion of what they're deploying, but it's a much reduced scope, and they get to focus on things that are ultimately probably more differentiators for them as a company. So we talked about that lack of visibility a few slides ago, and with AWS, you get that ability to be able to have an inventory at all times of what you're running in your AWS account or AWS accounts, be able to see what data storage you're using, be able to see what data is stored, and you have control over that data. So you can define who is allowed to access the data, the services that control where your data is stored, and you get to actually, if you want to implement the encryption that you want, you have full access and control of your data. So you can decide, how do you want to encrypt it? Do you want to encrypt it at the client side? Do you want to encrypt it at the server side? What kinds of keys do you want to use? What kind of a key management system do you want to use? That's all within your control as a customer. And being able to control who has access to that data, you have the ability to use a very fine-grained identity and access control service, so that you can make sure that resources and people have the right access, but they only have the access that they need. They're not able to go beyond the access that they would normally need to be able to do their jobs. And so you can also reduce that risk a lot more, because AWS offers a lot more ability to do automation and continuous monitoring, so that you are able to regularly watch what's going on with your workloads and your data and your applications, as well as be able to automate changes or deployments to ensure that they're consistent, and you reduce any intentional or unintentional human errors. And then if you have some existing workflows or operational processes that exist already, you can streamline those and fold in AWS services where appropriate to help you ultimately simplify the way that you're doing security and compliance reporting. We take our customers' security and data privacy very seriously. As I mentioned before, we have a professional security team who is working to help ensure that the AWS platform is meeting the requirements that our customers are giving us. And one of the key things that we do here is that we allow our customers to help them meet their data residency requirements. So AWS has 20 different regions around the world where customers can choose to run their workloads and store their data. And so that could just be the fact that they want to be able to store their data in a place that makes sense for their business customers. But it could also be to help meet data residency requirements. There are some customers who operate in certain industries or in certain parts of the world where they're regulated that they need to be able to store their data in that particular region. So these 20 different regions allow our customers to store their data and meet those residency requirements. And the reason being is that each one of these regions is constructed to be completely independent and autonomous. from all the other AWS regions. So one region doesn't depend on another region in order to be able to be up and running. And AWS does not replicate your data outside of a region by default. So when you store your data in an AWS region, that's where your data is going to stay. The only way that that data would move is if, one, you as a customer actually execute on code or API calls that would actually cause the data to be moved, by your choice, or you implement and choose and turn on features in AWS storage services that say that you are requesting that AWS replicate your data from one region to another region. Other than that, the data stays where you've stored it. Allows you to have that privacy as well when it comes to encryption. You can use the AWS Key Management Service or our Cloud HSMs, or really any key management service that you want to be able to encrypt your data. You're able to comply with those local laws by actually not only storing it in the AWS region, but actually being able to control who can actually access that content. You can lifecycle that content. You can put rules in place that would move that content to lower levels of storage, or delete that data entirely so that you are able to maintain and live up to any compliance requirements you have. And it ultimately is allowing you to build services and tools that are actually going to allow you to maintain compliance when you're running on top of AWS. So we talked a few minutes ago about the AWS part of the overall AWS platform, and that really boils down to the shared responsibility model. So when you're running on AWS, no one party has full responsibility when it comes to security. The customer has some responsibility, and AWS has some responsibility. So AWS is responsible for the security of the cloud. So that boils down to the infrastructure and the physical facilities that AWS actually operates and runs the infrastructure that powers the AWS cloud. And then we're also responsible for the software related to the kind of the core foundational services around compute, storage, network, and database. These are the parts that AWS is responsible for, and these are what our customers are building and running their solutions on top of. So then customers are really responsible for their security in the cloud. So that is, them turning on and using any specific security features of AWS services or specific security-focused AWS services. And also, the customers are responsible for determining how are they going to encrypt their data at rest and in transit, determining what their network configuration is going to be and what network protection controls they're going to be, determining how they're going to harden their operating system, coming up with patching schedules for their operating systems, any applications or platforms that a customer implements on top of AWS, they're responsible for the security of those applications and platforms and workloads. And most of all, customers own their content when it's stored on AWS, which is great because they get a lot of flexibility in choosing which services they're going to store in and how they're going to store that data. But they also are responsible for making sure that they have the right level of access control for that data and that they are putting the appropriate level of encryption and protection on that data. So each party has its own responsibility, and together you're able to arrive at a very secure final solution. And there are lots of different security solutions that exist in AWS, whether they're considered an official security service or they provide some level of security. There's lots of different things that customers can use to help them when it comes to implementing their security goals on AWS. A couple of those that exist here are in the identity and access management space. And the first one here is the top one, the identity and access management service. This is what you're using to define users and roles for who or what can ultimately access your AWS accounts. You're going to use IAM to construct policies that determine which AWS services and which actions within those services or a person or thing can actually use in your account. And you can also apply conditions to those policies that help say which things need to be present and true at the time that you're making this API call for me to be able to actually allow you to be able to access this particular AWS service. AWS Organizations is another important service because it allows you to start getting into that multi-account strategy. So we have lots of customers who are moving beyond running just one AWS account. They're using many AWS accounts to help them segment groups or workloads or different stages of the software development lifecycle. And organizations allows them to easily create an account, first of all, through one line of code, but then apply policies to all of those accounts, outlining which services are whitelisted and blacklisted for the use in that account. So it's starting to allow customers to have more controls for this new growing strategy around using multiple accounts. When it comes to detective controls, there's a couple of key things here. The first one is CloudTrail. Like this is like the thing that you want to make sure that you have turned on in order to be able to track every one of the APIs calls that are happening against your AWS account. And it's great for operational, security, and just compliance type work. It allows you to be able to go in and see who made an API call, when, which API did they call, which parameters did they pass, and what was the result of that, to be able to actually verify, why did this thing change, or this thing changed, is that a security risk, or does that violate our security policies, or to be able to go back from an audit perspective and be able to show who accessed or who didn't access this particular resource to be able to prove compliance or not. Amazon Guard Duty is another really cool tool when it comes to the detective controls. And so Amazon Guard Duty is our threat detection service that is working to protect workloads that you're running in your AWS account, as well as your overall AWS account. It is taking in data from multiple AWS data sources, using those to either report on signature-based security items or behavioral-based security items, and letting you know when you may have actionable security findings that you want to take action against for your AWS account or your workloads. When it comes to infrastructure protection, there's a couple of key things that I'd highlight here. One is the Amazon Virtual Private Cloud. So the ability for you to actually define your own private network space inside of the AWS cloud, where you can then launch resources and run those and build out a virtual network that you define and you control. You can define which things are publicly available and have access to the internet, which things are privately available. You can carve your network up into multiple subnetworks. You can create multiple networks and link them together, or run things completely private. And you can link these virtual networks up with your on-prem infrastructure through a VPN or our Direct Connect service, which provides low latency type connections all the way into the AWS cloud. And then AWS Systems Manager is another really cool tool here. And it is an agent-based solution that runs on either EC2 instances or an on-premise environment. And it allows you to be able to do perform remote code execution against your operating systems that that agent is running on, whether it be applying patches, whether it be getting an inventory of what's currently running on that device, whether it be just like a straight-on configuration of that operating system. Systems Manager is there to help you to be able to operate and run one command against many pieces of infrastructure all at the same time. Data protection, there's lots of things in here. We're going to talk some about the key stuff in a minute, so I'll skip that. But an important thing here is that the ability to have that server-side encryption or that data at rest protection, and being able to actually turn that on and use our key management service with many other AWS services to help ensure that you are using keys that are tied to your account and controlled by you as a customer, but are protecting your data at rest on the disk. And then incident response, being able to actually identify that something has gone wrong and that it needs our attention to actually be able to take action against it. So config rules that are there to automatically go and run and evaluate the compliance of a particular AWS resource once it's changed, whether it be that means that it's created or it's been updated, and help you determine, is this in a good state or not? And if it's not in a good state, to actually be able to take action against that resource. And then AWS Lambda, which has lots of use cases when it's outside of security, because it's just, it's basically functioning as a code. It's running in response to AWS events. But when it comes to security, you actually can use Lambda as a method of being able to respond to an event. Config rules could detect something is wrong. It could call a Lambda function afterwards to correct that. You could have your own internal monitoring that detects that, this is wrong. We know what the automated response should be. Let's call a Lambda function that will go and run that code and actually correct or isolate this resource. And it allows you to go and be able to scale and automate and not rely on a human for every step of your particular workflow where you may be dealing with security incidents. Now, I want to spend just a couple more minutes before I hand it over to Kevin, just talking about HashiCorp Vault and the AWS Key Management Service. So, with HashiCorp Vault, there's that master key that's super important. That's what's needed to ultimately be able to seal and unseal your vault, and that's really the keys to the kingdom. You want to make sure that that is protected and you can get at it at all times, and that you can use it to help be able to access the secrets that you're ultimately storing in the vault. And there is some overlap between the key management service and HashiCorp, but there's also some really cool use cases where they can operate together and actually deliver more value to our customers. So when we talk about the key management service, just a really quick overview is that The key management service is a managed service at AWS. It focuses on the durability, the availability, and the scalability of running a key management service. You create master keys that are either uploaded by you from a key you generated somewhere off site. You can create your own master keys, or you can use a data key that's specific to a service. But these keys are always tied to your AWS account. These master keys then generate data keys that are used to actually protect the data within the AWS service or the applications that you're using. You can create policies that will govern how those keys can be used, as far as who can access them and which API actions against the key management service are actually allowed to call. And all of this data is logged. Remember, I talked about CloudTrail a few minutes ago. All your interactions with the key management service are through an API. And so every one of those API calls is actually logged in CloudTrail, so that you can have full visibility around who's making encrypt calls, who's making decrypt calls, who's creating new keys, who's deleting, rotating keys, etc. All of that is fully visible for you to be able to make sure that you have the right level of control over your actual key management. And there's a couple of key benefits around key management service, around kind of how you can take control over your keys. One, you get to control who can manage and use your keys, and that's through those policies I talked about a few minutes ago. You can define conditions as far as when those keys can be used by using encryption context, which actually requires that a few extra pieces of information are provided when the data is encrypted, and then whoever is decrypting that data needs to provide those same pieces of data in order to be able to access it and decrypt that key. And I think that's a really cool feature. I like it a lot. You can control when keys are deleted. You can actually control when keys are rotated as well. And you can use these keys outside of just maybe the AWS environment or even AWS encryption services. It's just APIs, and we have purpose-built SDKs for actually being able to just take and use it and implement the key management service inside the applications and the code that you're writing, to be able to just deal with your data. Your code could be running 100% on-premise, and you could still be accessing the AWS key management service and taking advantage of some of the benefits that service provides while you're running your workload in another environment. Now, specific to the HashiCorp Vault is the unseal process, which I know Kevin is going to show us even more of in a few minutes. But at a high level, the key management service offers the place for you to ultimately store that master key. And Hashi has been able to implement the vault in a way that whenever you are unsealing that vault, it will reach out to the key management service and request the data key to actually be able to go in and ultimately unseal that vault by providing that key that the vault needs to be able to say, yes, you have control of this key. I am okay with you being able to unseal this vault and make it available for usage. So with that said, I'm going to hand it over to Kevin, who is going to take you through a little bit more detail on Hashi and a few demos to help round this out.
Thank you, Scott. So I'll go ahead and hand this over to Kevin. All right, Kevin, you should be good to go.
All right, excellent. Hi, everyone. Assuming you can see my screen, we'll go ahead and get this started here. All right, perfect. Then we'll get started. All right. So yeah, thanks so much for the introduction with AWS. Certainly, like Scott said, we're going to get more into KMS and the auto unseal feature. But let's kind of level set a little bit. I think we've kind of got with regards to security, I think we've kind of got the core fundamentals in place with a lot of with all of our like perimeter, our internal firewalls, our intrusion detection and prevention. We have our development teams on board to secure their applications. And even though we may be using the most advanced techniques and technologies, we're still behind the curve. So why is that? Well, it's because we think what we're doing is proactive, but we're actually being very reactive. And think about it. Everything that we have put together, all of our firewalls, all of our appliances, all the software that we put together is based in response to something that's happened. It's something that's happened in the past, something we're aware of now. It's all very much reactive, and we can try and think of some new things, but honestly, people out there who are trying to get into our data are very creative, so we don't really know what they're up to next. So that still leaves a vulnerability. So all those security methods do need to be there. They need to be in place, but there's still a pretty big gap between our secured perimeter and our customers' data. So, if any one of us, God forbid, any one of us, our companies were to be compromised, we don't want to be the next one in the news. We don't want to be the ones who are standing before Congress having to give an account of how this happened. So what we want to do is we want to try and protect that data. So these potential threats are compounded by today's environment, our operating environment, where we're moving to the public cloud. We have private cloud, we have public services, and a whole mix of all this stuff. And we've moved from an environment that it's a very well-known, a static environment where we control every single thing that happens in that environment, to a much more dynamic, a much more fluid operating environment. So with regards to a dynamic environment, HashiCorp has kind of identified the 4 basic elements of that. We've got our operations, which that's kind of our, automatically coding out your infrastructure, building it out. Terraform handles it very well, especially with hybrid environments. And we also have our security, which we're talking about now, Vault. We have networking. Console is our product for that. That deals more with service mesh, service discovery, mutual TLS authentication between services. And we also have our development, kind of our development layer, which is really more of how your applications are running. So that's more like what Nomad does for us. So it's a scheduler. So let's have to manually advance here. So HashiCorp is our answer to managing secrets. So what exactly is a secret? Well, a secret can be anything, passwords, private keys that we know about, but really it's anything that allows privileged access of any kind. So when you look at any of the major security breaches over the last several years, they're not always from the outside. And even those that are on the inside, it's not necessarily a malicious employee. It just so happens that they had access and they themselves were compromised. So our data, we can't just assume that because we have our perimeter up that our data is safe. And anyone who actually has that kind of access is generally going to be more of a target. So as we move to the public cloud and more of a public domain, we find ourselves in the middle of the shift of going from static infrastructure and dynamic infrastructure, and we need to be able to secure what we have in our dynamic, really even in our static as well. So we go from, let me go ahead and advance our slide here. So we go from our high trust networks where we have a clear security boundary. We have all of our resources are secured by their IP addresses. In other words, we care about every single thing that is on our network, every single resource. But that doesn't scale well at all, and it doesn't really help us transition to a low trust environment. So Vault approaches security with a little bit of a different mindset. So it assumes that we're operating in a low or a zero trust environment. So the connections are going to be made across public networks, and that we'd rather know who exactly is knocking on the door before we give out any kind of information whatsoever. So think about for a minute, how do you in your organization manage secrets? You use text files, you use spreadsheets, maybe they're secured, maybe they're not. I've kind of seen the whole gamut. When you see, are they in a central place? Probably not. Maybe they are, I don't know. I've seen a lot where they're, each kind of team manages their own secrets. But that's not really the best scenario. And even more so, how do you incentivize your people to store their passwords safely? What if someone doesn't work for you anymore and they leave the company? Do you have all the credentials that they need to continue on doing their work? And especially when you have workloads that are spread out across the region, across the country, the globe, you have a much larger surface area to have to secure. So this is where Vault can kind of help out with some of these things by helping you with consolidate your secrets so you don't have the secret sprawl. It gives you a centralized, really tightly controlled secret store where you can grant access based on trusted identities. It also provides several access methods that'll best suit your organization, whether you're using, you want to use the UI, you can do that. If you want to use the command line interface CLI, you can do that. The API gives you so much flexibility. You can actually wrap in a lot of Vault functionality into your new and existing applications. And it also allows you to manage data both at rest and in transit. So Vault manages identities through trusted sources. In fact, a lot of them that you're probably already using, whether it's Active Directory, whether it's LDAP. For AWS customers, you may be using IAM, and there's plenty of others as well. And Vault gives you the ability to have fine-grained control over which users and applications have access to which specific secrets. So we have a ton of things that Vault does, but today I kind of want to show you a few things that Vault does around secrets management and data encryption. And so with that, I am going to go ahead and switch over to show you guys a few cool things that we can do here in Vault. And okay. Peter, you see my screen?
Yes, we can.
Perfect. All right. So just real quick, to back up just a little bit and touch back on what Scott was telling us about KMS and the auto unseal. So just a real quick touch on that. He explained a little bit, and the seal function is just how it works is you can seal it. There's two ways you can seal it. You can seal it manually if you suspect there's your network's been compromised. You can seal it manually, or just by default, every time you restart Vault, it's going to be sealed. Now, that sounds fine and all, but what if you need to make a small configuration change, something like that? You have to gather together all the key shards and pull together, having at least enough of a quorum to be able to unseal Vault, and that can take more time than you really want to give up. So this idea of auto unseal is what we work with KMS. If you have like Cloud HSM through AWS, you can use that as well. But KMS is certainly pretty easy to set up. The scenario that we're looking at today is assuming that we already have Vault running. We've already put a few secrets in there, and we kind of got really serious about Vault. Now we realize that Vault rocks, and we want to put it into and actually start using it for all of our secrets management internally. So you don't want to really start over, but maybe you want to start integrating it into what you have so far. So we're actually going to migrate from a Shamir's secret, the shards, to using AWS KMS to store our master key. So what we're going to do is we're going to start with, let's take a look at what we have for our configuration so far. It is pretty simple. We have a storage, just file storage. You can actually, there's several different backends you can use. If you want to use console is going to be probably your highest performant, but you can use a number of different databases, data stores, whatever it is that you'd like to use. But it's pretty basic configuration. But what we want to do is we want to add this clause here. This is a seal clause saying that we're going to use AWS KMS. We're going to be running out of the US, the Oregon region, and this is our key that we have in AWS. That's our KMS key ID. So let's go ahead and run that. And let's take one more quick look at our configuration, make sure it's in there, everything looks good. So we're going to go ahead and restart Vault. So let's take a look at Vault status. Hold on, let me get back in here. There we go. Service. So now we see that Vault is sealed. Look at this line right here, it is sealed. But a couple of things that you don't normally see when you do a Vault status is a couple of lines here. So we've got unsealed progress, 0 of 3. As you notice, we have a total of 5 shares and a threshold, so we need at least 3 keys to unlock it. And we have the seal migration progress is in progress, which is true. So we want to go ahead and complete this process, and we can do that by providing it with 3 of our unsealed keys. And what that looks like is we're going to go ahead and say, hey, we're going to unseal this, but we're also in the process of a migration from our local keys or our key shares to using KMS to store the master key. So we're going to give it those three of those 5 unsealed keys, and we're just going to do that real quick. And there we go. So now if we do vault status, it is now unsealed, and we no longer see that we're in progress. Now let's just make sure it works. So if we say service vault restart, and we do a vault status again, as you saw before, it was sealed by default. Now it is not sealed. But there's no need to have all these key shares for our recovery. So let's go ahead and map this back down to a single recovery key. And we can do that fairly simply by, this is part of the migration process if you're not starting from scratch. But what we're going to do is we're going to initialize a read key here. We're just going to tell it we want 1 key. And we do that. Now it gives us this this token here, this number used once token that ironically we have to use 3 times. So it's number used 3 times. And we're going ahead and use, let's take a look at our next script. And so this is actually to finish up the read key here. So we're going to read key 1 key share. We're going to pass it the token, and then again 3 of our 5 unsealed keys to complete the process. So now we have a single key, and if we do a vault status, and this key can be used as a backup to unlock vault should KMS when you can't reach KMS. So once again, we are unsealed and we have a single key as a recovery key. So now we've got Vault all set up. Let's kind of put this thing into use. We already have a couple of credentials in here, but we want to set up a database because ultimately that's where our data is going to be stored for application. Maybe we already have a database. In this case, we do have a database, and it's a MySQL database. But we want to be able to kind of start moving to more of a dynamic environment where we don't just hand out static or long-term users and passwords, because at any point they can get compromised, especially if they're stored in an application configuration. So let's take a look at setting something like this up. So Vault has a whole number of secrets engines as well as authentication methods. By default, they're all off. So you just go in and turn on whatever it is that you need at the time that you need it. There are default mount points. You can change mount points, and I actually have I'll show you that here in a couple of minutes, where you can give it a different path so you can enable the same engine at different points, especially for different lines of businesses. So first line here, we're going to go ahead and enable the secrets database engine. We're going to write our configuration here that allows Vault to communicate with the database. So we've got our username, our super secret password, our connection string, and we're going to tell it that the allowed roles are app role, and that's the one that can access this particular configuration. So moving on to our configuration for the role, the database, which is actually this right up here. So this is how it correlates. The DB name here should match this DB name up here. All we're going to do is we're going to be able to create a user that, you don't necessarily want to do this in your environment, but this one just kind of mimics what root would be able to do as well. So we're enabling the database engine. We're creating a configuration to access Vault or access MySQL. And by the way, the plugin name right here is for MySQL. We actually support all the major databases, probably I think 6, 7 different major plugins out there that you can use for this. So let's go ahead and run this. Okay, so everything's been created. Now we want to create a couple of policies so that we can apply these to some users. And let's take a look at our operator. So we have operator. The operator is going to be able to manage the roles, be able to manage the credentials, read, create, update, delete, whatever they need to do, as well as static secrets. And our application developers, we only want them to be able to read static secrets at this time. We don't need them to be able to manage anything else, but maybe they need to get into a particular application and they can access those credentials there. It's a real simple process to use these policies. We simply just, vault policy right, and we give it the name and we import that file. So those have been created. Now let's create a couple of users. Again, fairly simple here. As I mentioned earlier, everything's, you have to enable things that you want to, so you don't have to worry about things being open and usable without your consent. So you do need to enable user pass that allows us to be able to put in a username and a password. So here we go. We've enabled it. We create James. James is going to be an operator. We've got Sally. She's one of our application developers. So let's go ahead and create them. All right, so that's all said and done. Let's take a look at what James can do. Just have to do that so it doesn't interfere. So let's log in. Now the default login is going to ask you for a token, but we're not going to have a token here. We're actually using username and password, so we'll use James. So now we're logged as James. James should be able to access the credentials for the database as well as the secrets, static secrets. So let's take a look and see if he can access the static secrets. And we'll take a look at creds. Boom, there we go. So he can access vault_user and super secret password. Let's make sure that he can also read the database credentials. There we go. So yeah, we actually just got a username and a password. And actually, I can keep running this and I can keep getting more, and I keep getting unique ones. Now, it's important to know here too that I've got the lease duration here for an hour, so it does expire. So you can actually configure your application to rotate those credentials on a frequent basis as well. And if we want to take a look at what Sally does, we can actually just kind of log in right here into the user interface. We'll say Sally and super pass. So here's what our Vault UI looks like. Sally doesn't have a whole lot of access. Cubbyhole is Sally's own, and every user can have their own place to store secrets, and nobody else has access. Even the root doesn't have access to this. So we go into secrets. We can take a look at the creds. It looks like she can look at the username and the password as well. So that's great. We have a couple of things set up. Let me get back in here to get everything set up. So how do we actually use this and make this usable? So we've got a couple of different authentication methods for AWS. You can use EC2 authentication, or you can use IAM authentication. EC2 is fairly simple to set up. IAM is a little bit more secure, has a little bit more features that you can use, a little more configurable, but we're just going to do a real simple method of being able to set this up using an EC2 authentication. So let's see what this looks like. Again, we're going to enable the authentication method for AWS. We're going to pass it over our keys, and we're going to create a role for the database policy. All we can do is read it and list it. If you look down here below, it's important to note that we have, we do assign it the DB role, but also we bound it to an AMI ID. There's actually about 10 different attributes that you can bind together. This is probably the least secure, but it's real simple just to be able to put something together for you guys. but you can use like an instance profile, you have a role, you can do any kind of mix and match, some tags, and you can make this a lot more secure. But for now, all I'm saying is that any instance that uses this AMI ID right here is able to log into Vault. So let's go ahead and get that started. Okay, so the server's set up. So let's go ahead and see if our application, which would be on this server, is able to do this. So this instance uses that same AMI ID. And let's take a look at what we've got here. So we're just going to do a quick, see what we're going to do here. So we're going to use the PK cert as the signature. So we're going to pull that from the metadata of the instance. We're going to wrap it into a payload that also says, hey, we're looking for the appdb role. Here's my signature. And we're going to go ahead and send this on over, and we're going to log in. And when we log in, it's going to send us back a token that's going to allow us to communicate back and forth with the server, with the Vault server, with whatever permissions we've been given. So let's go ahead and get that done. Okay, so you can see right here, we actually have the token here. Now let's actually see if this thing works. So we're going to do a call using our API. We're going to, in the header, we're going to give it the Vault token, and we're going to generate those credentials for us. And there we go. So this application, any application on this system is now able to obtain dynamic credentials for the database. So now we've got everything set up for the database. Actually, let me just show you one other thing, just kind of what happens whenever that actually doesn't work. If it was, for instance, some other AMI, let's just get this back in here. Same thing. So if we were to run the same script, you see we have a null here. So it couldn't figure out. Let's go ahead and take a look at what the output was. And it tells us straight up, hey, you know what? This AMI ID doesn't belong to this app role, so you can't really do anything about it. So now that we've got that all set up, let's actually take a look at how we can encrypt our data using encryption as a service. And again, this is another engine that we're going to enable. Only focusing on a couple of lines in here. So we're going to enable our transit engine. So secrets enable transit over here. We're actually giving it a path for a line of business, a different line of business. And then we're going to go ahead and create a customer key, which will be used to encrypt and decrypt the data. So there we go. That's all set up. And now let's go to what our application would be listening to. So this would be our application that's writing to the database. Let's go ahead and refresh this. So let's just say this is an HR scenario. HR can see social security numbers, they can see birthdays. We want them to be able to use that information to be able to do their job. So, but we don't want anybody to be able to get that information and use it for any kind of malicious purpose. But guess what? It's actually stored in the database like this. We may have all of our policies and all of our protections and things, but the fact is that if someone were able to get into this database, they can see the raw data is there. You know, if I had a record, you know, I just put some name in here, 1990. Still, you know, it's records, you know, it just created it. It's just plain text. So that's no good. If someone were able to compromise this, we'd be in trouble. So let me go back over here and let me enable this engine, our transit, because right now it's just we've got it set up. It's ready to go. We just kind of are bypassing it for the moment. So let's go ahead and use that. And we'll run again. Okay, so back to records, we see everything here. You notice nothing's really changed because we haven't actually altered any data. We're just simply um, enabling an engine and making it useful for this. So let's go ahead and add a record this time, and I'm going to put in somebody else. And there we go. Okay, so again, HR can see everything that they need, but this time we actually have it stored in the database securely. So if someone were to compromise this data, they're kind of at a dead end. I mean, what are they able to do? They can't really get anything and it's nothing useful. You can come back in and you can update this record, say right here, record number 4. And now that we have this enabled, the next time you write to it, it will be able to encrypt that data for you. Couple of things to note here is if you see this V1 right here, so that's the version 1 of the key. So you can come back in and rotate the keys, and Vault will be able to still access anything that you needed to encrypt or decrypt from previous versions. It does archive the key for performance reasons, but it does allow you to do that. So that kind of wraps up our demo. Hopefully that was pretty useful. Let me go ahead and go back over. I've got a couple more things to cover with you guys, and we will go back to our, there we go. PowerPoint. And let's go back down to, there we go. Okay, so pretty much everything that I showed you today, I did with our open source product. So there wasn't anything necessarily intrinsic to open source. However, I did make reference to like Cloud HSM or any other kind of HSM technologies that you use. That is an enterprise feature. So let's just touch real quick on what makes the difference between, when we step it up from Vault being just this really cool secrets management server to an enterprise level. What does that look like? Well, the main thing is that it not only allows for you to have some support, it's also geared more towards the enterprise features such as compliance, governance, multi-data center, policy management, especially where business rules are concerned, and as well as team collaboration. It actually enables all these features that make it much easier to run at a larger scale. Some of the features that are included, like I said, the HSM integration. Sentinel is our policy manager, and it allows you to take those business rules that you want to apply that aren't just necessarily technical rules, they're actually the business rules, and you can actually enforce rules that way. Replication is a real important one between data centers, between regions. You have both DR replication as well as performance replication. Have read replicas. Namespaces help you partition different lines of businesses, so you can kind of give control to one, give control to another, and never shall the 2, 3, 4, 6, 8 meet. Multi-factor authentication, just a number of things that really are geared a lot more toward an enterprise level. But definitely, everything that I showed you today, I just want to encourage you to get out there. If you haven't played with Vault, get out there, download it. We've got a lot of documentation. It's real simple to get set up and get running. Other than that, I think I kind of ran us out here accidentally of time, but I want to turn it back over to Peter and just say thanks. And maybe if we have some time, we can answer a couple of questions.
Yeah, we did have just a couple questions come in. So I just wanted you to reiterate. So we had a couple questions about the UI that you showed for generating credentials with Sally. That is currently an open source feature, correct?
That is correct. That is correct.
Excellent, thank you. So at this time, we do want to open it up for any questions. So feel free to enter them into the chat box. They could be either on the AWS portion or on Kevin's portion in the demos. And I also want to thank Kevin and Scott for their time today to go over an excellent amount of information for us.
Thank you for having me.
Yep.
Absolutely.
Thanks. It's great.
Yeah. So Kevin, we did have a question come in just about the storage of secrets within Vault. Could you go into a little bit about where secrets are actually stored and kind of how they're protected when you save them into Vault?
Sure. So secrets are stored. We have a number of different backends that you can use. The preferred method is console. So console, I mentioned it earlier. It's our networking. It does network service mesh, service discovery, but also has a very fast key value store. So what we do is we store secrets in there. Mostly that's static secrets. We try not to store secrets that don't need to be. So for instance, when I showed you the demo about the encryption as a service, we don't actually store any of those secrets or any of that data in console or in whatever store that you have. So Vault doesn't actually store those, but for secret store, you can use a file, just a local file. You can use any one of the like MySQL or any other kind of data store that you have. But like I said, console is kind of is our preferred method. And definitely when you're in enterprise, we do that's the supported method of storing the secrets.
Excellent, thank you. Scott, this one might be one that we can have you explain a little bit. So we did have a question about FIPS validation. Can you explain a little bit about how Cloud HSM supports FIPS? And then if we could have Kevin, maybe you answer just about how we support Cloud HSM.
Sure. So FIPS, I have a note here on that, so that's what I'm grabbing for. The AWS Cloud HSM has a FIPS level validation that is at, level 2, potentially, yes. So FIPS 140-2 level 3. So the Cloud HSM is validated at the level 3 level for FIPS already. So that is available for you to use at that level today.
And yeah, for Vault, it's FIPS 140 level 2, and it is and seal wrap, I believe. So yeah, we do have that protected for you.
Excellent, thank you very much. So we did have a question come in about EC2 permissions. So Kevin, can you just elaborate a little bit more about what you made? And then Scott, the follow-up, I guess, is that they were asking about EC2 permissions for KMS specifically. So I guess could explain a little bit about maybe how those interact together.
Sure. So we actually wrote we actually provided the authentication method working with AWS within Vault. So we've got 2 different authentication methods for EC2. So that would be the actual EC2. So that's an instance ID. So there are certain attributes that an instance would have, such as, like I mentioned earlier, you've got the AMI ID, you've got the instance profile, you might have tags. So any one of those, or not any one of them, any combination of those, you can pull together and you can say, this is what makes an authenticated system that I will allow to log in. And so that's what the EC2 authentication method does. IAM, the IAM authentication method requires a little bit more work. So you do need to create you need to create a role, you need to create an instance profile and have that applied to the system. And then that role using, again, instead, you want to enable the AWS authentication method, but instead of saying the auth type is EC2, you would say the auth type is IAM, and you have any number of attributes. Much the same way, you're just going to give it that instance profile and tell it that this profile is, and this role is allowed to access the Vault server. And that way, what's nice about that is you're not having to embed credentials into an AMI or anything like that then feeds back. And I mean, it's kind of the old way of doing things. We try to avoid embedding secrets in things because that's where things can get compromised. So the more we can kind of abstract that and say, this is a known identity in my network, then you can authenticate. And so that's kind of what's kind of behind the EC2 and the IAM authentication methods.
And I think that's really important because especially when you start talking about scale and like multiple multiple instances running the same application, all needing the same credential, for them to be able to identify themselves with a common pattern that says all of this infrastructure represents this application, and for Vault to be able to confidently bend that back, I think is super important. For the kind of the modern day cloud native type applications.
Thank you, Scott. We did have another question in just along those same lines. What configurations are required for the KMS based unseal on the AWS side? So is there anything special that you need to do to set it up from AWS in order to enable it for Vault?
Sure. So KMS, you definitely want to create your own a new customer master key. You can either create one that KMS creates and manages through its hierarchy, or you can upload your own key if you generate it in some HSM or somewhere offline. You can upload that as your own key as well. But you need to have a customer-defined key, which will then be used to generate it. You will want to scope the policy on that key to limit it to be able to only be called by the HashiVault resource, so that the instance that it is that is making that call, so that you're making sure that not anybody can get access to those keys, and you'll even want to limit the HashiVault one so that it's only really using it to retrieve the keys, not to create new keys or delete keys. And then you'll want to use the monitoring. You can probably build some custom monitoring with your CloudTrail files to say, look, anytime something that is not this resource does this action against this KMS key, I want an alert. So, because it means that something is not right or somebody's trying to interact with that. So that's how, at a high level, that's the approach you would take to scope that down.
Thank you, Scott. Kevin, we did have one more follow-up about the transit engine that you showed. Can you explain a little bit about when those fields are getting encrypted and kind of how they get encrypted versus decrypted, and like when that actually happens in the process?
Yeah, so so again, you're going to have a client token on the client that's going to be able to log in and has access to the role. So you have an application in that sense. This particular application was written in Python. So you're sending over the client token along with secretness that should be an encrypted communication over to Vault anyway. So it sends it over. Vault encrypts it. It prepends the word Vault just so that you can be able to parse that out and know it's encrypted, and it just sends back. It sends that back. So the data is encrypted in that token, but Vault doesn't actually store any of that data. It just simply encrypts, sends it back. You send back that key, that full encrypted payload. You send that back to Vault. To that same path, to the same transit engine using the same key, and it will decrypt it for you, so you can then display it in the application. It's a pretty robust. You can actually send it up to, I think, about 32 megabytes of data, which is pretty huge. I wouldn't imagine, for sensitive data, it's usually not. It's pretty big. But ultimately, it is exactly what it is. It's transit. It's not really storing anything. When you saw me create the customer key, that's actually created by Vault. Vault has a number of different secrets engines behind the scenes. But that is an AES 256 with, I think, a GCM 92 so there's actually about 5 or 6 different methods that you can use. By default, it's AES GCM 92 for encryption. So hopefully that answered that question.
Appreciate it. Thank you. All right. So I think we're going to wrap up on questions here for now. We had some great ones come in. I apologize. We're a little bit over time on the webinar. So first and foremost, I want to thank Scott and Kevin very much for their time today. I hope that you learned a little bit. Hope you all learned a little bit more about strong enterprise security level types of standards being implemented in cloud environments, specifically in AWS. As a reminder, this session is being recorded. We're going to do a little bit of post-processing on it, and then we'll make it available to everybody who registered for the webinar. If you have any additional questions, you can feel free to reach out to us anytime, and I want to wish everybody to have a great day. Thank you all.
Thanks, everybody.
Thanks.